Hello and welcome to another exciting math lesson. Today we're going to talk about compound inequalities. Here we go. Alright, so during this lesson you're going to learn how to understand the difference between and or in compound inequalities and learn how to solve these compound inequalities. Our vocabulary today is compound, meaning a combination of more, or I should say two or more, combine more of two or more things, so just two or more things. Alright, an inequality is an equation where one side of the equation is greater than or less than the other side of the equation. The two sides can also be equal to one another as well as greater than and less than. Interval notation is something that we've already talked about. It's a notation for to represent an interval as a pair of numbers. The numbers are the endpoints of the interval. Parentheses and or brackets are used to show whether the endpoints are included or not included. Okay, so the inequalities and. So when comparing two inequalities, you want to find an and comparison. We're looking for where the points will be true in both statements, or where the points are shared. So where we had shared common points are the two inequalities. When graphing each inequality on a number line, I really highly suggest to use this number line. You'll be looking for where the two inequalities overlap on the number line, and you'll write your answer in interval notation. So this would be an example of an and comparison. Okay, so let's do an example problem. So it says find negative 3x plus 5 is greater than 17 and 4x minus 12 is less than or equal to 8. So the first thing I have to do is I have to solve for x in both of these. So let's start with this one. I'm going to solve for x. So I'm going to subtract 5 from both sides. When I do that, I get negative 3x. Those 5's cancel out. Greater than 12. Okay. Now I have to get rid of that negative 3. So negative 3 is being multiplied by x. So we're going to divide by x. And I get x. Since I'm dividing by a negative number, my inequality is going to flip. And we get negative 4. Okay, so there's one of my my inequalities. Let's solve this next one. I have 4x minus 12 is less than or equal to 8. I'm going to add 12 to both sides. And I get 4x is less than or equal to 20. Divide both sides by 4. And we get x is less than or equal to 5. Okay, so that's only one part of it. We want to see how we can combine these and how we can see where they overlap and where they don't overlap. So what I'm going to do is I'm going to draw a number line. We have 0. We have negative 4. We have 5. Those are our points of interest here, right? So we're going to do this negative 4 first. X cannot equal negative 4, so I'm going to use an open circle at negative 4. And I'm looking for things, this inequality here says x has to be smaller than negative 4. Smaller is always to the left. Okay? So there's my negative, x is less than negative 4. The next one I have is x is less than or equal to 5. So since it can equal 5, I can use a filled in circle, meaning it can equal 5. And we're looking for x is less than, which is to the left. Okay, so what we're searching for here is we're looking for where that overlaps. Well, it starts overlapping at negative 4, right here. Right? And then it continues all the way to the left. So if I write that in interval notation, I would say from negative infinity, because we always start from the left, the smallest, not included, all the way to negative 4, because I can't include negative 4 right here because it's not included in the red line. So I'd say from negative infinity to negative 4. All right. want you to try one now. So the very first thing, so stop the video and try it before you watch the solution. Alright, so first we have to solve this inequality. Very first thing we're going to do is multiply by a -5 on both sides. Those -5's cancel out. I get x plus 6. Since I'm multiplying by a negative, my inequality changes, and we get -10. Then we're going to subtract 6 from both sides, and we get x is greater than -16. Alright, now let's do this other one. X minus 8 is greater than or equal to 5. I'm going to add 8 to both sides. X is greater than or equal to, let's see, 13. Alright, now we can draw our number line. We're going to kind of shift our number line since our numbers are big here. I'm going to put 0 over here. We can just say this. Oh no, we have that negative number. Forgot that I have a negative here. Alright. You don't have to have this like completely accurate here, so a lot of the time what I'll do is I'll say, well, -16 is going to be somewhere over here. 13 will be somewhere over here. Because we're just looking for where they overlap and things like that. Okay, so -16 is my orange. Right here, x is greater than -16, so it cannot equal. And we're looking for things that are bigger than -16. So that's things to the right. Next, I'm looking for things that are greater than or equal to 13, but it can equal 13. Right? So I have a filled in circle at 13, and things that are bigger than. So my overlap here is everything this way, right? So now to write that in interval notation, I'm going to say, well, what's the smallest number that both lines have in common? Have in common. Well, that would be 13. 13 appears in both. Because this is a filled in circle, I can use a bracket. And they're going to be in common the rest of the way to infinity. Alright, so now we're going to talk about the OR comparison. When comparing two inequalities and you want to find an OR comparison, you're going to be looking at points that are true statements in both inequalities, or that are or which points are shared between the two inequalities and which points are not shared. And this one's kind of hard, because you're looking for essentially any point that appears on one or both of these. Okay, so in graphing comparison, we'll be looking for two lines where the two lines overlap and where they do not overlap. They just have to exist in one of the two comparisons. We will write this in interval notation again, and here's an AND comparison, or this OR comparison. You'll see that OR in between. Let's see how to do this. Okay, so once again, the first step is the same. We're still just going to solve for this inequality. So I'm going to subtract 3 from both sides. I get -4x is less than or equal to -8. Then we have to divide by a -4, since -4 is being multiplied by x. Since I'm dividing by a negative number, my inequality switches, and we get x is greater than or equal to -8 divided by -4 gives me 2. So there's one inequality. The next inequality, we have x minus 5 divided by 3 is greater than or equal to 4. I first need to multiply by 3 on both sides to get rid of this 3. We're trying to get x by itself. Those 3's cancel out, and I get x minus 5 is greater than or equal to 12. Okay, then we have to get rid of that 5, move it to the other side. So we're going to do the opposite of what it's doing, so that's addition. we get x is greater than or equal to 17. Okay, so this part is exactly the same. I'm still going to draw my number line. We're going to say we have 0, we have 2, we're going to say 17 somewhere over here. Alright, so we're still going to draw this. So at 2, it can equal, so I have a filled in circle. It's things that are bigger than 2. So it's everything to the right. Then at 17, I have a filled in circle because it can't equal 17. And it's anything bigger than 17, so that's also to the right. So for this OR comparison, I'm looking for anything that is overlapped, so all the stuff right here, but also anything that appears on at least one of the graphs, which means we also include all of this green stuff right here. So my lowest point that appears in at least one of the graphs or both is at 2. We use a bracket. And then we go all the way to infinity. Don't include that. There's my interval notation. Now I'd like you guys to try, before you watch it, pause the video, solve these inequalities, and then watch the solution. Alright, so we have x plus 7 is greater than or equal to negative 8. We're going to subtract 7 from both sides. X is greater than or equal to negative 15. Perfect. And then we have x plus 4 divided by 7 is less than 3. We're going to multiply both sides by 7, and we get x plus 4 is less than 21. Then we have to subtract 4 from both sides, and we get x is less than, let's see, 17. Alright, now we can draw our number line. We have negative 15 somewhere over here, 17 somewhere over here. So negative 15 is a filled in circle, and it's anything bigger than negative 15. So that's anything over there. And then, let's do that one in red. Alright, then my orange one is x is less than 17, so I have a filled in circle here, and less than is to the left. So with this OR comparison, it's anything that appears on at least one of the inequalities or both, so it's a combination. So essentially, as I'm looking at this, I have everything from negative infinity all the way up to, even though I have this circle right here at 17, it's covered on this red inequality, so it's okay all the way to infinity. So everything's covered on at least one of the inequalities, so I would say from negative infinity to infinity, and there is my interval notation. If you're struggling with this or you have more questions, please come and see me or one of our fantastic tutors, and we'd be happy to help you. Have a great day. Take it easy, guys.